Before we start, let's have first an activity. This activity is entitled You Belong With Me. So I will show you objects and all you have to do is to identify which does not belong to the group. So let's start. So we have here a pen, a marker, a comb, a pencil, and a color pencil. So the question is, which does not belong to the group? Okay, that's right. So comb does not belong to the group. So let's have the next. So we have here a carrot, a pancake, a potato, a cabbage, and an eggplant. So question, which does not belong to the group? That's right. So pancake does not belong to the group. Let's have now the last one. So here we have a blouse, a pants, a short, a skirt, an eyeglass, and a t-shirt. So the question is, which does not belong to the group? That's right. So an eyeglass does not belong to the group. So our activity has something to do with our lesson for today. And our lesson for today is all about sets and Venn diagram. So before we start, let's have first the learning objectives. So we have here, at the end of the lesson, the learner should be able to first define and illustrate sets. Second, differentiate the different types of sets. Third, perform operations of sets, such as union and intersection of sets. And the last one is to illustrate relationships of sets using Venn diagrams. To begin with, let's define a set. So what is set? A set is a collection of objects. Objects in the collection are called elements of the set. So for you to understand, let's have an example. So here we have the collection of counting numbers such as 1, 2, 3, 4, so on and so forth is a set. So each counting number is an element of the set. Next, we have the collection of pencils in your briefcase is a set. And each pencil in your briefcase is an element of the set. Okay, so we have here a reminders. So first, sets are usually designated with capital letters. Elements of a set are usually designated with lowercase letters. And the collection or elements can be listed within the braces. Sets can be defined into two ways. It can be by using roster method, and the second one is the rule method. So let's talk about the first one, which is the roster method. So let's define what a roster method is. So the roster method of specifying a set consists of surrounding the collection of elements with braces. Next, we have here an example. So, the set of counting numbers from 1 to 5 would be written as like this. So, as you can see, the counting numbers from 1 to 5 is in the braces. So, here we have a braces with its element 1, 3, 5, 7, so on and so forth until 9007. So how can we write it in a sentence? So we write it as is the set of odd counting numbers less than or equal to 9007. Next example, we have here a braces with its element 1, 2, 3, so on and so forth. So how can we write it in a sentence? So here we are. So it can be read as is the set of all counting numbers. So now let's proceed to the second method, which is the rule method. So let's define what a rule method is. So the rule method or the set builder notation has the general form. Okay, So variable, then it is read as variable such that the descriptive statement. So the vertical bar in set builder notation is always read as such that. Okay, so let's have an example. So it can be read as the set of x such that x is less than 6 and x is a counting number. So how can we write that? So as you can see, there's a braces, and inside the braces there are 1, 2, 3, 4, 5, and these are called the elements. Next, we have here x such that x is an odd number less than 10. So how can we write it as a raster method? So we have here braces with its element 1, 3, 5, 7, and 9 because these are the odd number that are less than 10. Next, we have here x such that x is a day in a week that starts with T. So how can we write it in a raster method? So we have here, okay, so as we know, the day in a week that starts with T are Tuesday and Thursday. Now, let's proceed to the different kinds of sets. So first, we have here the universal set and subset. So let's define what a universal set and subsets is. Okay, so the universal set denoted by capital letter U is the set of all possible elements used in a problem. So take note, all possible elements is called universal set. Next, when every element of one set is also an element of another set, we say that the first set is a subset. Okay, so for example, set A is equal to 1, 2, 3, 4, and 5. And set B is equal to 2 and 3. So we can say that B is a subset of A. And the notation we use is B subset of A. Next is the empty set. So let's define what is empty set. So the empty set is a special set. It contains no elements and is usually denoted as braces without an element or a circle with parallel line. Okay, so the empty set is always considered a subset of any set. So we have here a question. Is this an empty set? What do you think? Is this an empty set? Okay, it is not empty. It contains element 0. So that is not an empty set. Next, we have here equivalent set. So let's define equivalent set. If the number of elements is the same for two different sets, then they are called equivalent sets. So the order of sets does not matter here. So it is represented as A or set A is equal to set B, where A and B are two different sets with same number of elements. So for example, we have here if A or set A is equal to 1, 2, 3, and 4, and B or set B is equal to red, blue, green, and black. In set A, there are 4 elements, and in set B, also there are 4 elements. Therefore, set A and set B are equivalent set. Next, we have here equal set. So, when we say equal set, the two sets A and B are said to be equal if they have exactly the same elements. Okay, so the order of elements do not matter also. So, it is represented as set A is equal to set B. So, for example, we have here set A is equal to 1, 2, 3, and 4. And set B is equal to 4, 3, 2, and 1. So as you can see in the example, they have exactly the same elements. In equivalent set, they have the same numbers of elements, and in equal set, they have exactly the same elements. Next, we have here the union of sets. So it says here, the elements of the union are in A or in B or in both. If elements are in both sets, we do not repeat them. So the union of two sets A and B is denoted as A union B. So it is written as capital letter U. So we have here an example. So in set A, we have the elements 1, 3, 5, 7, and 9. And in set B, we have the elements 1, 2, 3, 4, and 5. And for us to get the union of sets, A union B is equal to, so we just combine or put them all in a braces. So we have here 1, 2, 3, 4, 5, 7, and 9. So remember, if elements are in both sets, we do not repeat them. Next, we have here the intersection of sets. So when an element of a set belongs to two or more sets, we say that sets will intersect. The intersection of a set A and a set B is denoted as A intersection of B. So in union, we use capital letter U. In intersection, we use inverted U. So for example, we have here set A is equal to the elements of 1, 3, 5, 7, and 9. And in set B, we have 1, 2, 3, 4, and 5. So we get A intersection B. So when we say intersection, it is the number that they are intersect or they have both the same. So we have here 1, 3, and 5. Now, let's proceed to the complement of a set. So when we say complement, it is the thing that completes or brings to perfection, or in short, something required to make a group complete. So the complement of a set is denoted by A or by A complement, as you can see in the PowerPoint. So let's have an example. So we have here union of set as 1, 2, 3, 4, and 5, and set A 1 and 2. So for us to make the group complete or the set A to be completed, we will get the complement of it as A. A complement is equal to 3, 4, and 5. So we are done in the different kinds of set. Now we will going to proceed to Venn diagrams. So Venn diagram were conceived in 1880 by John Venn. So John Venn was a British philosopher and logician. So when we say Venn diagram, it shows all possible relations between a finite collection of sets as well as logical relationships. In short, it is a way of picturing relationships between group of things. To draw a Venn diagram, you have to draw a rectangle which represents a universe and a circle or circles which represents a distinct objects or elements. In the context of Venn diagram, universe does not refer to everything but to everything under a consideration the given situation. Now we will going to use the Venn diagram to determine each of the following sets. Okay, so we have here an illustration. So now we're going to get the union of set or the universal set. So when we say union or universal, we have to get all the elements on this Venn diagram. Next, we have to get the A complement. So when we say A complement, we have here the set of square and triangle. Next, the set of elements in universal or union that are not in A complement. So the answer is the set of dollar sign, capital M, and 5. So now let's try to illustrate sets using Venn diagram. So it says here, using the numbers 0, 1, 2, 3, and 4 till 9, illustrate the sets A as 4, 7, and 9, and set B as 1, 2, 3, 4, and 5 using the Venn diagram. So let's proceed. So we have here a rectangle with two circles. So the first circle will serve as the set A and the second circle will serve as the set B. So as you can see, 4 is in both sides. So 4 will serve as the intersection of the set. So we will put the 4 in the intersection of the two circles. Next. So, what's next? So, as you can see, 7 and 9 are only in set A. So, we will going to put 7 and 9 in set A. Next, how about the set B? So, in set B, we will going to put 1, 3, 2, and 5. So, like that. Next, as you can see, we don't have numbers 6 and 8. So, and 0. So, we will put it outside the circle like this. Okay. So, that's how we use Venn diagram in sets. So, for better understanding, I have here a Venn diagram, but I will use colors to indicate the intersection, union, or etc. So first we have here the intersection. Members of both set A and set B. Okay, so as you can see, the color violet here will be our intersection. So A intersection B. So the color violet is the intersection. Next, let's proceed to the union. So members of set A or set B or both. Okay, so as you can see, all the circles will have a color of violet, and that is A union B. Next, let's proceed to the complementary members not in the set. Okay, so the violet color are the complementary. Okay, A complement. Next, so we have here the universal set. So when we say universal, it is the all members. So just like that. That's a universal set. Next, subset. All members of set A are in set B. Okay, just like that. So A is a subset of B. Like that. So that's end our lesson for today.